Hello friends, welcome to BSS Studies. I am Bala. Today I will explain about law of conservation of energy. Law of conservation of energy. We already learned law of conservation of momentum. What is law of conservation of momentum? Total momentum is constant. So in law of conservation of energy, here energy is neither be created or destroyed, but total energy is neither be created nor destroyed, but energy is transferred to one to another form, keeping total energy Here, law of conservation of energy defines energy is neither be created nor destroyed, but energy is transferred to one to another form. Energy is transferred to one to another form, keeping total energy is constant. Here, law of conservation of here main point is total energy is constant. At any position, total energy is constant. Okay. So, this is the definition. Energy is neither be created nor destroyed, but total energy is constant. That is the main point. Okay. First note down, I will say example. For example, here I am taking RAM and at certain height a ball is there. This is height. Okay. Here height represents length of this side. Okay. Height represents length of this side. Here when they mention height, we have to say this have potential energy, because potential energy is equals to mass into gravity into height. Okay. When there will be height, this object have potential energy. Okay. So, if I push this ball, it comes downwards. So, during mid of the way, here one of the position, here this position have both potential energy plus kinetic energy. Okay. During mid of the way, in this position, potential energy plus kinetic energy will be there for this ball. After coming downwards, it have kinetic energy. Okay. Here, we have to take this as theta. So here, at certain height, it have potential energy. During mid of the way, from this position, it have potential energy and kinetic energy. Here, when it comes downwards and it is rest position, it have kinetic energy. When it comes downwards, not rest position, sorry. When it comes downwards, it have kinetic energy. Okay. Here, for this example, how total energy energy is constant means, this is one of the example. Here, how total energy is constant means, here I am taking potential energy is equals to 5 joules. Here kinetic energy also 5 joules only. During this mid of the way, it also have 5 joules only. Total energy is constant. Okay. If potential energy have 5 joules, kinetic energy also have 5 joules only. And during this mid of the way, it also have 5 joules. Okay. So this is total energy is constant. One of the example. Another example. I am taking simple pendulum. Okay. This is simple pendulum. So this is one of the extreme position. This is also one of the extreme position. So what is the position of this? Mean position. Okay. So here potential energy is minimum, kinetic energy is maximum. Okay. Because it is in mean position. Means there is no height. So it have kinetic energy maximum and potential energy minimum. Okay. So at extreme position, potential energy is maximum, kinetic energy is minimum. Okay. At extreme position, it have potential energy maximum, kinetic energy minimum. At mean position, potential energy is minimum, kinetic energy is maximum. Okay. So this also same, because it is also extreme position. Potential energy is maximum, kinetic energy is minimum. See, I will say potential energy is maximum, kinetic energy is minimum. Okay. So this is one of the another example, simple pendulum. Here how it applies, how it works. See, here I am taking potential energy is equals to 5 joules. Here kinetic energy is 0 joules because it is at certain height. So kinetic energy will not there. So 5 plus 0, 5 joules. At extreme position, 5 joules. So here I am taking kinetic energy is equals to 5 joules and potential energy is 0 because this have no height. Okay, this position will not apply potential energy because there is no height. Okay, so this have 5 plus 0, 5 joules, and this also have 5 joules. So total energy is constant. Okay, so this is one of the example of law of conservation of energy. Okay. Next topic, work and energy theorem. In this theorem, we have to prove one formula. Okay, let's prove the formula. I am taking this is one of the object M and I am pushed with force F and it displaces some distance. Okay. Initially this body goes with speed U and finally V. Okay. Here, according to second equation of motion, according to second equation of motion, here what is second equation? V square minus U square equal to 2AS. Okay. So here we have to find force. Here what is force? Force means force is equals to mass into acceleration. Here they gave acceleration. So we have to substitute acceleration value. So here acceleration is force by mass is equals to acceleration. Okay. It is transferred to this side. So it gets divided with force. Okay. So here v square minus u square equal to 2 force by m. Force by mass into s. Okay. So m gets transferred to this side. So mass into v square minus u square equals to 2 into force into displacement. Okay. So here 2 gets transferred to this side. So half m v square minus u square equals to force into displacement. So here force into displacement means work. Work means energy. Both are equal. So this is work energy theorem. Because change in work done is equals to energy. Okay. Change in work done equals to energy. Okay. This formula represents change in work done is equals to energy. Okay. So this is work and energy theorem. Here the formula of work energy theorem is this. Okay. So what is work and energy theorem? Means here in this case total energy is constant and here change in work done means change in these two work done is equals to energy. Okay. So that is called work and energy theorem. Okay. So this is work and energy theorem. So here work and energy topic is lesson is completed. We have to do some problems. So first problem, a body of mass 8 kg has an energy of 16 joules. Find its velocity. Here they give mass is equals to 8 kg. Energy is equals to 16 joules. So here we don't know what this energy is kinetic or potential. So in this question they gave clue. What is the clue? Find its velocity. Velocity means we have to use kinetic energy. In potential energy, velocity is not there. So we have to use kinetic energy. So here kinetic energy is equals to half mv square. Okay. So we have to find this velocity. If we transfer these two to this side, so ke by 2 ke because it gets transferred to numerator. So 2 ke, this gets transferred to denominator. So 2 ke by m is equals to v square. Okay. So this square is transferred to this side and it gets root 2 ke by m. Okay. Here k is equals to half mv square and we have to find velocity. So these two quantities are gets transferred to this side. So 2 ke by m equals to v square and v is equals to root over 2 ke by m. Okay. So v is equals to root over 2 into 16 by mass 8 kg. Okay. So 2 1s are 2 3s are. Sorry, 2 4s are. Okay. 4 1s are 4 4s are. Okay. Here root over 4 means 2. Because 2 into 2, 4. Root over 4 means 2. So here velocity is equals to 4 meter per second. Okay. So this is the answer. Here second problem. Two bodies of equal masses have kinetic energy 4 joule, 36 joule. Find the ratio of velocities. Here two bodies of equal masses. Here they give two bodies have equal masses. Means I am taking one of the body MA and another body MB. So here MA is equals to MB. Masses are equal. So here KEA equals to 4 joules because this is first one, and KEB is equals to 36 joules. Okay. Then find the ratio of velocities. Here we already learned velocity is equals to root over 2 into kinetic energy by mass. Okay. So here they are asking VA is to VB. So here what is VA? VA is equals to root over 2 into 4 joules. 2 into 4 joules by masses are equal. So MA. I am writing MA is to root over 2 into MB, VB, KB, 36 joules by MB. Okay. So here root gets cancelled. 2 gets cancelled. MA, MB gets cancelled because both are equal. So 4 ones are 4 nines are. So 1 is to 9 is the answer. Okay. Here masses are equal but kinetic energy they gave. So they are asking velocities, ratio of velocities. So ratio of velocity is 1 is to 9. Here like this we have to do by this formula. Okay. So this is second problem. Third problem. What is kinetic energy when mass and velocities are equal? Here they are asking what is kinetic energy and mass and velocities are equal. Here mass is equals to velocity. So these are equal. So I am taking both quantities as m. Okay. Here I am taking both quantities. Both quantities as m. So if we find kinetic energy is equals to half mv square. So we have to substitute only m. So half into m square. So m into m square means m cube. So half m cube. So this is m cube by 2 is the answer. Okay. Here mass and velocities are equal. So I am taking these two combination as m. So if we find kinetic energy half mv square, half into mass into m square equals to half into m cube is equals to m cube by 2 is the answer. Okay. This is third problem. And here fourth question. What are the examples of law of conservation of energy? Here we already learned law of conservation of energy. Here in that total energy is constant. Okay. So if we write examples like roller coaster. Roller coaster means in like this will be there. This is the route of roller coaster. Like this it will go. So in this energies are constant. Okay. So this is one of the example. We already learned ram with ball ram with ball like this. Okay. So third one we already learned simple pendulum. Simple pendulum. Okay. So these are the three examples of law of conservation of energy. Okay. So this is fourth question. So fifth question. Two bodies having same kinetic energy moving with velocities 2 meters per second, 4 meters per second, and find the ratios of masses. Okay. So taking Ka equals to Kb. Kinetic energies are equal. So A body, B body. Here velocity of A equals to 2 meters per second. And velocity of B equals to 4 meters per second. And they're asking MA is to MB. Okay. So here, what is the formula of mass? Here we already learned Ke is equals to kinetic energy equals to half mv square. Okay. If we transfer these terms to this side, so here 2 kinetic energy by v square equals to mass. Okay. So this is the formula. I am writing. So here MA is to MB equals to 2 into kinetic energies are equal. So Ka by V square. Va square means 2 square. 4 is to 2 into Ke means kinetic energy by 4 square 16. Okay. So here these two terms gets cancelled because 2 gets cancelled and kinetic energies are equal, so gets cancelled. So 4 1s are 4 4s are. So here 1:4 is the ratios of masses. Okay. So this is fifth problem. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.